Hi guys! Salamat sa inyong patuloy na pagsubaybay sa ating ginagawang discussion about statics of rigid bodies. In today's discussion, we shall be showing the application of the method of members in the analysis of structure. Pero bago tayo magpatuloy guys, sana ay subscribe natin itong ating channel. Nang sa gayon ay lagi tayong updated kapag meron tayong bagong uploads. At kung maaari ay ma-share natin ito sa ating mga friends upang sila man ay nai-inform din of our discussions. Guys, ito ang problem. For the frame shown in the figure, determine the horizontal and vertical components of the hinge force at B and the vertical and horizontal components of the reaction at the support C and E. So in this particular figure, we have here bar D, vertical bar D, B and E is attached to inclined bar ABE, and ABE is supporting a pulley where the pulley support another load of 600 pounds here. So in this problem, we would like to solve for the pin reaction at this joint as well as the reaction at the support C and E. Sa ganda rin klase ng problem guys, kinakailangan maintindihan natin kung ano ba yung mga basic concept na dapat natin gamitin kapag tayo ay nag-a-analyze ng structure, particularly kapag gumagamit tayo ng method of member. Una, dapat nga ba talagang method of member ang gamitin natin? So kinakailangan makita natin muna ito bang structure ay tinatawag nating frame. At para malaman natin kung siya ay frame, dapat meron tayong member na subjected to kay bending action. So kung titingnan natin itong A, B, E na member, because these are maybe subjected to the forces acting at A, at B, and at E, therefore we would expect that that member is a three-force member. And hence, that member will be subjected to kay bending. Similarly, we're going to analyze this vertical bar D, B, C, because there may be forces acting at D, and at B, and at C, therefore, this member is subjected to more than three forces that will make it in equilibrium. As such, this member is also called a three-force member. So makatuwid, itong structure nito shall be called a frame, and we can analyze the structure using method of member. So sabi, pag nag-start tayo, nag-analyze tayo using method of member, kinakailangan identify muna natin, i-analyze muna natin, i-consider muna natin yung kabuuan ng structure as FPD. And find out, meron baga o baka meron tayong mga unknowns na pwede agad ma-solve using the conditions of equilibrium. If these unknowns can be defined, its direction, then the direction must be indicated. But if not, we can simply assume the direction of those forces acting on the member. Tingnan natin itong point, joint C dito or support at C. Because the support at C is a hinge support, so asahan natin that there would be a horizontal and vertical reaction. So because I do not know the direction acting at horizontally at C, I can assume it to be directed to the left. Diba? And I will be calling it as C sub H. Samantalang dito sa vertical component ng C, pwede natin ma-define yan. Halimbawa sabihin natin kung ako'y magtitake ng moment dito sa ito, di ba? So yung epekto nitong 600 will produce a counterclockwise moment effect about A. And for it to be in equilibrium, there must be another force that would produce a clockwise moment. And that should come from a force that will be acting at the resultant or reaction at C. And hence, we would expect that the reaction at C vertically should be directed in the upward direction. So I have here the C sub B, which I do not know the magnitude. Later on, we shall be computing for that. Similarly, if this E is also a hinge, so asahan natin that it should also be subjected to horizontal and vertical components. At dahil nga meron na akong in-assume na CH is directed to the left here, for equilibrium to exist, this horizontal directed to the left must be balanced by another force that should be directed to the right. So, na-assume ko ngayon dito that at E, it should be directed to the right, and I'll be calling it as E sub H. Similarly, the vertical component at E can also be identified. Kasi itong 600 na ito will be producing about C a counterclockwise moment. A counterclockwise moment. And that counterclockwise moment must be counteracted by a clockwise moment that should be coming from the reaction at E. And for E to produce a clockwise moment, therefore, the direction of the vertical component up at E must be directed downward. Kaya inassume ko yan, kaya that is directed downward, and the magnitude is a business that is not yet known. Okay? Now, if we're going to consider this whole structure as FED, mapapansin natin na we have 4 unknowns acting on the structure. At dahil nga 4 unknowns yan, hindi natin basta-basta siya masosolve kasi kulang yung ating conditions of equilibrium na mabubuo. Okay? Dahil meron tayong mas higit na mas maraming unknowns kaysa dun sa conditions of equilibrium na pwede. Pero ang tanong ay ganito. Pwede ba na kahit ilan ay masolve agad natin ang ilang mga unknowns? Kung titignan natin ang situation, if we're going to sum up moment about E, all the 3 forces such that E sub B, E sub H, and this C sub H will have the moment about E. And we can calculate right away the magnitude of C sub B. Ganon din, if we will take moment about C, all the 3, C sub H, C sub B, at itong horizontal component ng E, will also create the moment about C. And therefore, we shall be getting a moment equation that involves E sub B, and E sub B therefore can be computed. Di ba ga? So, subukan natin. Let us try to consider that this force is a 600 pound force coming from the weight of this block. As such, if we're going to sum up moment about C equal to 0, and from here, we can solve for E sub V. If we will be taking moment summation here, we can solve for E sub V here. Assuming natin that the counterclockwise moment is positive. Therefore, what shall be the moment produced by all the forces acting on the structure about C? Let us try to find out what shall be the moment that this 600 will be producing. It will be having a moment arm equal to the total moment arm that this would have from C shall be the sum of 4 and 8. And therefore, the moment shall be equal to 6 multiplied by 12, and it will be producing a counterclockwise moment about C, hence that would be positive. So I will have here 600 multiplied by 12. And then what about the moment produced by E sub B? E sub B would have a moment arm of 8, and it will be producing a clockwise moment about C. Therefore, that would be treated as negative, considering that this convention is positive. Hence, I would have here 8 E sub B, or E sub B multiplied by 8. And all this summation should be equal to 0. Diba? So from this equation, we can solve E sub B. And E sub B, as indicated, it is downward as it acts on E. Now, afterwards, we can solve for C sub V. Diba? C sub V naman tayo by summing up moment about E. Now, if we're going to sum up moment about E, then we can solve here C sub V. And again, if we are going to consider counterclockwise, or assuming that counterclockwise direction of moment be positive, therefore, what shall be our moment equation? The moment due to this 600, will have this 600 will have a total moment arm from E equal to the sum of 4, 8, and 8, and this is equal to 20. And this will be producing a counterclockwise moment about E, hence the moment produced shall be positive, and the magnitude shall be the product of 600 multiplied by 20. While this C sub V, C sub B will have a moment arm equal to 8, and the moment produced that by this C sub B about E will be in the clockwise direction, hence that would be a negative, and the product will be C sub B multiplied by 8. And all of this, when summed up, must be equal to 0. So that when this will be simplified, we can compute for C sub B, which is equal to 1,500, and directed downward, C sub B is here and directed upward as it acts upon C. Diba? And if we're going to look at this value, okay, we cannot solve anymore the value of CH and EH because we do not have any more equations that can be used to solve for EH and C sub H. So for the meantime, pwede naman natin siya munang iwan, ano? At dyan natin ipapasok yung tinatawag nating use of the members in solving for the other unknowns in the problem. So what are we going to do? Now, if we are going to imagine that the pins are removed. Kunwari, tanggalin natin yung lahat ng pins in the system. Ano? Tanggalin natin yung pinat A, tanggalin yung pinat D, pinat B, pinat C, at pinat D. So what shall we do? So if we are going to remove all the pins, so we can separate completely all the other members from each other. Pwede natin mapaghiwa-hiwalay yung lahat ng members from each other. Diba? And so, if we're going to isolate the free body diagram of the pulley, itong pulley na ito, no? Kunwari, i-isolate natin siya so that this will be isolated, this part here, diba? And from this pulley, we can show all the forces acting. What are those forces acting on the pulley? We have the 600, okay, we have the cable that runs over the pulley in this direction, from this up to that, and so we show this here, no? So that at this end of the pulley, or this cable, there is a weight of 600 pounds coming from the weight of the back. So I have here 600. And since the other part of the cable is not yet known, so we can simply label this as an unknown and let us just call it as T sub D. At this point, tinanggal ko ngayon yung P, so I have to show here the action at that point, at that pin, at A, the action of this inclined bar ABE upon the pulley. And assuming that the action of that bar is resolved into components, therefore I would have here the vertical components of the force exerted by this bar ABE upon the pulley, and this is called A sub B. Similarly, there will also be a horizontal component of the action of ABE upon the pulley, and this will be treated as A sub H. So you will notice here that the pulley now is isolated completely as free body diagram. And because this is part of an equilibrium, therefore, this pulley will also satisfy the condition of equilibrium. And what are those conditions of equilibrium that this would be satisfied? Now, if we're going to take moment summation about at A, diba? Kung sinam up natin yung moments about A, you will notice and you can find that the value of TD, and it will give us a value of TD equal to 600. But so that if this TD shall be given now 600, okay, we will have now two remaining unknowns, and that is A sub B and A sub H. Now, if we're going to apply summing of forces vertical, okay, this summation of forces vertical will now give us a value for A sub B, and the value will be equal to 600 pounds. So that AB now will be defined as 600 pounds. And similarly, we're going to sum up moments, sum up forces horizontally, okay, on this condition, on this free body diagram. This will give us a value of A sub H equal to 600 pounds. So that A sub H now here will also be equal to 600 pounds. Now, if we're going to isolate this member DBC, okay, as free body diagram, let us try to draw this FBD. Okay, then this DBC would have now the pins removed. Let us now try to show those pins that are removed from DBC. We have here at this point, okay, the pin at D. We also have here at this point the pin at B, and we have here the pin at C. Okay, these pins are given the position or the distance from each other. So let us define the distances from each other. The distance between DB is defined here at 10 feet, while the distance between BC is at 6 feet. Now, after we have isolated the member DBC, let us try to show how this DBC is interacting with the other members of the structure. Now, at this point D, this DBC is interacting with the pulley by means of the cable. So we would expect, therefore, that at point D, there would be a tension exerted by the cable acting horizontally at point T, and so we have to show that force, and the magnitude is already taken to be equal to 600, and therefore we define that as T sub D equal to 600. Similarly, at this point C, we already have taken this because this is the vertical component of the reaction of C, and which is already computed to be this value. So we have to show therefore the force exerted at this by the support at C, and the magnitude is given at 1,500. At C sub H, we have identified, or we have assumed it to be directed to the left, so we have to show it directed to the left and show the magnitude to be an unknown equal to C sub H. Then we have to show the force exerted by the member ABC upon this member DBC at point B. Since we have removed the pin, we have to show the force exerted. And since we do not know the magnitude or the direction, we can assume the direction and simply label the magnitude by any kind of symbol. So let us imagine that this is acted by horizontal force. Let us call it as B sub H and expect that there will be a vertical force, so we will be calling it as B sub V. Now, if we're going to look at this free body diagram of the member DBC, you will notice that we have this member is subjected to 1, 2, 3, 4, 5 forces. Meron tayo ngayong 5 forces na nag-act on the member. Ang kagandahan naman to, we already have known the 2 of the 5 forces. We have known this vertical component and we have known this horizontal component at T sub D. Sa makatuwid, there will only be remaining 3 unknowns in the member. And because this is in equilibrium, so we have here a system of non-concurrent forces in equilibrium. Therefore, the other 3 unknowns can be solved by applying the conditions of equilibrium. Diba? So, if we're going to solve for B sub V, this one, diba? So, since wala namang ibang force nag-act, so we can solve for B sub V right away if we will sum up forces vertical. So that if we will be assuming that upward direction be positive, therefore our equation becomes 1,500 minus B sub B shall be equal to 0. And from here, masolve natin itong B sub B. Diba? And it will be directed down to the right as it acts upon the member DBC. Now, if we're going to solve for BH, ito naman sosolve natin, no? We try to eliminate, we try to take moment summation about C, ba? And we consider counterclockwise direction as positive. Now, what are those moment dues about C by all these forces? Tingnan natin. The moment due to the 600, it will have a moment arm equal to the sum of 6 and 10. And will be producing a counterclockwise moment. Therefore, the moment will be 600 multiplied by 16. Diba? Whereas the moment due to B sub H will have a moment arm of 6 and therefore, and it will be producing a clockwise moment about C. Therefore, it will be a negative and the value is B sub H multiplied by 6 and the sum of which must be equal to 0. So that from here, we can solve for B sub H equal to 1,600 and it will be acting horizontally as it acts upon this member DBC. Then afterwards, what shall we do? We can now solve for what? We can now solve for C sub H, this value, by summing up moment about B. So that if we will be summing up moment about B, all this BH, BV, and C sub V will create no moment, hence they will be eliminated in the equation. What would appear only is the moment due to the 600, whose moment shall be the product of this and this 10 kilonewton, and it will be producing a counterclockwise moment, therefore positive, so that we have here 600 multiplied by 10. And the other one shall be the moment due to the C sub H, and whose moment arm is 6, and it will be producing a clockwise moment about B, and therefore that could be considered to be negative C sub H multiplied by 6, and all of this must be equal to 0. So when we simplify this value, we can solve for C sub H to be equal to 1,000 pounds, diba? We can now go back to the entire structure as FBD and we can solve for the horizontal component at E sub H, diba? So how are we going to solve for E sub H? By summing up forces or acting horizontally, and that is equal to, so treating horizontally directed to the right as positive. Therefore, what will be our equation? Our equation becomes E sub H minus C sub H shall be equal to 0. But C sub H is already computed at 1,000. Therefore, if this will be substituted here, we can compute for E sub H minus 1,000 equal to 0. And therefore, E sub H shall be equal to 1,000. And that's how we have computed for the forces acting at the P and at B and the components at the reaction C and E. If necessary, it's better to consider preparing a summary of your answers, particularly how the forces shall be acting on a particular member. Like for example, I would like to consider the action at the P and at B. It will be 1,500, but in that case, how it is directed? It is directed downwards as it acts upon member B, C, D. Because if we were to consider how it is directed when it is acting on the other member, it should be directed in the opposite direction. Similarly, the value of piece of H is 1,600 is 1, and it is directed to the right as it acts upon BDC. Okay, furthermore, we have the reaction of piece of H, which is computed to be 1,000, ito yun, and directed in the rightward direction or leftward direction. Then we also have C sub B, which is this one, and the value is 1,500 directed upward. The other one is E sub H, which is directed 1,000 directed to the right, as indicated in this illustration. And then finally, we have E sub B, which is equal to 900, which was computed earlier, and the direction is downward as it acts upon that member. Hope guys that you are able to follow the presentation that I have given you, particularly on the use of method of numbers in analyzing a structure. Sana ay nasundan ninyo yung ating ginawang discussion at sana ay patuloy nyo akong susubaybayan sa ating patuloy na ginagawang discussion about statics of rigid bodies. Once again, thank you very much for watching.